What components need to be installed on worker nodes in a Kubernetes cluster?
In a Kubernetes cluster, worker nodes are responsible for running application workloads. To function properly, worker nodes require the following key components: Kubelet, container, runtime like Docker, containered, CRIO, etc. Kube Proxy, network plugin like CNI, Calico, Flannel, Cilium, etc. Storage plugin like CSI, Container, Storage Interface, NFS, AWS, EBS, etc.
Kubelet, what it does. Tell some issues or challenge that you faced with Kubelet.
Kubelet. It is an agent that runs on every worker node and communicates with the control plane. It ensures that the containers specified in the pod spec are running. We had an issue where pods were stuck in a container creating state. After troubleshooting, we found that the Kubelet service was not running on one of the worker nodes. Restarting the Kubelet service fixed the issue with following command: systemctl restart Kubelet. Challenge faced: the problem. In one scenario, Kubelet was failing due to a mismatched Kubernetes version between the control plane and worker nodes. Solution: upgraded the worker node using command kube adm upgrade node to match the control plane version.
Container runtime, what it does. Tell some issues or challenges that you faced with container runtime.
Container runtime. It is responsible for pulling images, creating containers, and managing their life cycle. Popular choices: Containerd, recommended, CRIO, or Docker. Docker is deprecated in Kubernetes 1.24+. During a migration from Docker to Containerd, we noticed that pods were failing to start. The error logs showed failed to create pod sandbox, RPC error, code, unknown description, failed to start container manager. The fix is: we needed to properly configure the CRI socket path for Containerd with the following command: updates the Containerd configuration file etc containerd config.toml file to ensure that Containerd uses systemd as the C group driver, which is required for Kubernetes compatibility. Sudo systemctl restart container d. Challenge we faced: the problem is some applications relied on Docker commands inside containers, but Docker was no longer supported in Kubernetes 1.24+. Solution: we used CRICTL, Container Runtime Interface CLI, instead of Docker commands.
Kube Proxy, what it does. Tell some issues or challenges that you faced with Kube Proxy.
Kube Proxy. It maintains network rules for pod-to-pod communication inside the cluster. Implements IP tables or IPVS rules to route traffic between pods and services. We had an issue where pods could not communicate with services. Running the command kubectl get pods and kube system. It showed error. Kube Proxy in CrashLoopBackOff. We fixed this by restarted the Kube Proxy daemon set with command kubectl rollout, restart daemon set /kube proxy and kube system. Challenge we faced: the problem is incorrect Kube Proxy configuration. It led to intermittent network failures. We used command kubectl logs-n kube system kube proxy to debug and reconfigured it with correct settings.
Network plugin, what it does. Tell some issues or challenges that you faced with network plugin.
Network plugin. It enables pod-to-pod networking across nodes. The popular CNI choices are Calico, Flannel, Cilium. When we set up a Kubernetes cluster, but found that pods on different nodes couldn't communicate, by running the command kubectl get pods-n kube system, we found error Calico node in a CrashLoopBackOff state. We fixed the issue, checked the logs with command kubectl logs-n kube system Calico node, found that IP auto detection method was incorrect, fixed it by setting kubectl set env daemon set /calico node -n kube system IP auto detection method can reach 8.8.8 .8. The challenge we faced. We used Flannel initially, but needed network policies for security. Flannel does not support network policies. The solution we have to migrate it to Calico, which supports network policies.
Storage plugin, what it does, tell some issues or challenges that you faced with storage plugin.
Storage plugin. It allows dynamic or static provisioning of storage volumes. The popular CSI drivers are AWS, EBS, CEPH, NFS, Rook, Longhorn. We found an issue. A stateful application using persistent volumes, PVs, failed to start. The error logs showed unable to attach or mount volume. We fixed the issue that we verified the CSI driver installation and checked volume attachment status with command kubectl get pvc-a. The challenge we faced, that storage volumes were not automatically unbinding after pod termination. The solution is we implemented CSI storage class with reclaim policy delete to handle cleanup automatically.